get mad at me. We're gonna see. Let me put this over here. Let's see it. Okay, so resistors in series have the same current. And then here's the other rule, is that the total voltage in a loop must add to 0. Okay? And what we like to think of is that, here, just so this makes sense, voltage across batteries. Batteries are things that look like this. That's positive voltage. And then voltage across resistors. So like stuff like this. This is negative voltage. Cool? Do we understand those rules so far? I'll show you how we use them later, but I just want to make sure, like, do we understand the rules so far? Lag test? Yeah, please tell me if the lag test isn't working. Why is the voltage in a loop always 0? Why does it always add to 0? Yeah, that's called Kirchhoff's voltage law, is what that is. Yeah, that's the voltage loop law. 8 seconds? Okay, not bad. Not the worst for lag. Okay. I need to screenshot that. Well, yeah, don't worry. I will save all of this so you can see all of it, like, later. You'll get like a PDF for this. Okay? So, let's look in the loop here, right? What happens, okay? So, let's do voltage loop. I mean, let's do that in blue. Let's do like voltage loop. You're learning this in physics too? Oh, that's cool. So, you have 90 volts from here. Oh, let's get this out of the way. Sorry. You have 90 volts from here. So we're going to say 90. And then you're going to have minus V1, because that's negative going across. The next thing we can do is we can use what's called Ohm's law, which says that V1 is equal to I1 R1 and V2 is equal to I2 R2. Okay? These will also help us out. The third little thing we have to do is called finding total resistance. Oh, the frame drop's getting bad now. Oh no. All right, I might change the Twitch streaming settings in a second here. The vertical's cool, but yeah, it's taking too much bandwidth though, I can tell. Okay, so finding total resistance in a circuit is that resistors in series add up. So for instance, R total is just equal to R1 plus R2 plus like whatever the other resistors are. And this is for resistors in series. This is what series means. This is series. Okay. So in this case, R total is equal to R1 plus R2. And so that's going to equal to 10 plus 20, which is equal to 30 ohms. Okay. So right here when they say R total, you can write out 30 ohms. Now when they want to figure out, for instance, I total, you can use Ohm's law to do it. V total is always the voltage of the battery. So here's the other little key thing here. V total is always the voltage of the battery. So in that case, the voltage of the battery is 90 volts. So this is going to equal to 90. But we don't really need that. The other thing we know from Ohm's law is that V is always equal to IR. So also, V total is equal to I total, R total. So in this case, 90 is equal to I total times R total. You're good. Times 30. And so that means I total is equal to 3 amps. Nice. So this will be 3 amps here. Okay. Does that make sense so far, servos? Like how we're doing this? Yes? Okay, cool. All right. Then we can figure out what these individual things are by either using the voltage loops or using Ohm's law. So the other key thing is that everything in series have the same current. So that tells me that I1 equals I2, which also equals I total. Here, so I1 equals I2 also equals I total. So I total was 3 amps. That tells me this is 3 amps and this is also 3 amps. And now to figure out V1, we can just do V1 is equal to I1 R1. Okay, so V1 equals I1 R1. And so that's going to be 3 times 10. And that's going to be equal to 30 volts. V2 is equal to I2 R2, which is equal to 3 times 20 volts, times 20 ohms. So that's going to be equal to 60 volts. And then here's the cool thing you should see here, right? 90 minus V1 minus 30 minus V2 minus 60 also equals 0. So now everything makes sense. Cool. Dun, 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 dun. Okay. You're going to do some practice problems? Okay, cool. All right. I hope this helps. These are all the rules you really kind of need. Once you know these, you can do other ones. So here, let me, I'm going to save this to you and you can work on it later. Okay. Say this is servos 1. Let's throw it on. So in the homework help Discord, I'm going to go here. I'm going to create a new post. I'm going to say servos. And then here you go, servos. Learn about circuits, dude. Okay. Jeff, let me know. Wait, I'm going to ask Jeff. Jeff, how bad is the frame drops? I might restart this and just like turn off all the Twitch vertical. If it looks like trash, just let me know, please. Yeah, I mean, like, is it watchable? The latency is kind of whatever. Good. Why is I1 and I2 and I all the same? It was bad. It got better. Okay. We're gonna just pretend it's still good. So that's just the rule for things in series. Things that are all in a line with each other. So when they go like this, those all have the same current. And then you'll learn later that things in parallel all have the same voltage. Frame drop's getting bad again. Okay. Alright. One sec. I'm going to fix that. So this is going to go to... Whose question was this? This was Servo's. Frequent freezing. We don't like that. Okay. Boo. Okay. One sec. Fixing. Again, thank you, people, for staying with me, staying patient as I figure this out. They don't have any way to really test this unless I do it live. How much do you pay for the bot? I pay a lot of money for a lot of things. It's so interactive, yeah. Okay, let me fix this. All right. All right, let's go to stream. We're not going to do auto. We're going to say 2 tracks. I'm going to set this to maybe 6K. Oh, it needs at least 4 then. Fine. Let it have 4. I'll do 7. I'm gonna rewatch this part because I think I'd actually learn this. Yeah, no, circuits are great. Circuits are great. Definitely, highly recommend. Cool. All right, nice. That question's done. Okay, I think this is running now. Jeff, let me know if it looks okay now. Freezing here, but let me reload. All right, let's see. Looks okay to me. Am I getting any frame drops? It's loading. All right, next question. Let's see. Spinny white circle. Oh dear. Why is it doing the spinny white circle? Oh, really? Buffering. More white spinny circle? God damn it. Alright, okay, one sec. One sec, trying again. Alright. Yeah, one sec. Let me... Because I don't see it on my side either. Here. Oh, I was there for a second? Oh, wait. I was back? God damn it. I just stopped it. Okay. I am back. Okay, great. And I think the vertical and the horizontal still works. Yeah. Okay, cool. Okay, thank you. Let me know again if it starts frame dropping, please let me know. Okay, let's see what's on the queue. Nice. Cool. Okay, so I actually have some interesting ideas, guys. Yeah, for the internet. Because I can't get better internet in my apartment. I literally just can't. It doesn't work. But apparently there's this thing called channel bonding. Because I learned this actually at TwitchCon from the IRL streamers. So what they do is they have multiple hotspots with different service providers. Like they have an AT&T hotspot, they have a Verizon hotspot, they have a T-Mobile hotspot, and then they splice all those connections together to like one super connection so that they never lose reception. And I was looking into it today. I'm like, okay, how many fucking hotspots do I have to buy to like chain together to make sure we have enough bandwidth to stream to different platforms? Yeah. Yes, Discord has 0 delay. Correct. Yeah, fun Dr. Gold's internet. Yeah. Yeah, you can chain the internet connections together. Apparently, you can split them. You can splice them. You can distribute it. Really rad, apparently. Okay, wave standing in wavy water. Notices that the depth of the wave varies in a periodic way. That can be modeled by a trig function. Yeah, Starlink is very expensive. Yeah, that would be like a couple $100 to do. Starlink is very pricey. Plus, I'd have to go find somewhere to mount it, and it needs a clear shot of the sky, which is hard if you're in an apartment. Yeah, it's called load balancing, and also like it's either called like load balancing or channel bonding. It's pretty cool. You connect like multiple internet connections into like one router and it starts distributing it. Okay. After 1.1 seconds and then every 3 seconds, the water just touches his knees. Between peaks, the water recedes to his ankles. Wade's ankles are 12 centimeters off the ocean floor and his knees are 55 centimeters off the ocean floor. Oh, okay, cool. So the min is equal to 12 centimeters. The max is equal to 55 centimeters. Exactly. Very good, Shantrix. Yeah. So the midline is equal to like the average of the min and max, which is equal to min. Yeah, exactly. Yeah, Laz, you're totally right. Yeah. So I might need to start doing that with like my Twitch stream. That'd be crazy. Do you know Thenoven's theorem? Yeah, I can do Thenoven's, yeah, for sure. Why is my chat not working on that one though too now? One sec. test. Okay, that works. But I don't think I'm seeing Discord. I wasn't seeing this working.
Nice.
Do it. Wow, thanks for the follow, Les. So min plus max divided by 2. So that's going to be 12 plus 55 all over 2. So that's equal to 67 divided by 2, which was, so that's 33.5. Yeah. Okay, and then amplitude is equal to max minus min divided by 2. 67 divided by 2. I think it's 33.5. But then the max minus the min, that ends up equaling 43 over 2. Oh, 67. God damn it. No. You got me again, Jeff. Stop it, dude. No, you didn't. You didn't just do it. No, he didn't just do it, dude. Stop, Jeff.
Disqualified. You done messed up, Aaron.
Oh my God, Jeff. Jeff, dude. From 41 timelines away. Alistair, that's too funny. He's got it, dude. Dude, I kept asking the students, like, how long do you think 6-7 is going to last? And they said at least till the end of the year. Apparently that's it. They said at least till the end of the year. I'm like, okay, fine. Okay. Amplitude. Okay, then we need to do period. So period is equal to... Wait, no. It's omega, right? Yeah, sorry. Or angular frequency? I think we just call this omega. Is equal to 2 pi over the period. Right? And so that's equal to 2 pi over 3. Wait. It just touches his knees. Yeah, that makes sense. That's the period is 3. It's because of the problems. Okay, cool. And then... Okay, and then the knees is the height, is the high point. Okay, so this is interesting. So we need the high point to happen after 1.1 seconds. Right, this is like the high point, and then it does this. You've only been seeing numbers less than 4. Okay, so this is a cosine function then if it starts here, right? So we're going to say this is equal to, or let's say depth d, right? So d of t is equal to the amplitude. So that's 21.5 times cosine. And then it's omega. So that's going to be 2 pi over 3 times t. But then it's being shifted to the right 1.1. So we're going to say t minus 1.1. Right? And then this is plus the midline, which is 33.5. Exactly, Chantrix. Yeah, cosine. This is cosine. Cosine peaks when it's at 0. But then this thing has been shifted over to the right. So that's why we have this term right here. This is a shift to the right. So I think this is it. You tell me. I believe so. It's correct. Cool. Nice. Good. Good question.
Well done. Well done.
This is Shanktrix. Nice. Oh, I need to fix. Let me fix the. I don't know why the. How to get mod? if you're here long enough, Servos, and I can trust that you're responsible, I'll give you mod. That's usually how that works. That was kind of math, honestly. I don't know if that was really physics. I was like, I need my Twitch chat. I need my TikTok chat to work. It'll work here in a second. How do I become mod? You're close, Reki. I just need to trust you a little bit. No, yes, not again, dude. Y'all with the 6 7s. Alright, I need this to work. Come on. Okay, there we go. Okay, now all the TikTok chats are coming in. Streaming is a very it's a lot of trial and error, honestly. It's not as simple as it seems all the time. Yeah. Yeah, see, now all that's coming in. Okay, cool. I'm gonna throw mustard at you. Let's do the next question, ladies and gentlemen. That would be... Yeah, okay, cool. We're gonna mark Shanktrix is done. Nice. Logan. Yo, what's up, Reki? Thanks for the hydrate. Sweet.
And the baby voice. And the baby voice. And Master Chief. Is Master Chief coming out too? Oh, wow. How do you get good at math? Practice. Practice is good. Jesus, what is this engineering question, by the way? What's up, Ricky? Yeah, no, the soundboard doesn't... Oh, wait, the soundboard doesn't...
Work on... It should.
My man.
I mean, the Halo sound stuff won't work. Because that goes through OBS. Okay, a submerged platform is to be held in place... yeah, exactly. Yeah, it won't work on Discord. Yeah, only OBS. Is to be held in place using a hydraulic jack shown below. The water in the reservoir is stationary, and the hydraulic jack is also filled with water. Is this a water barometer? Yeah, I guess so. There's a seal at A to prevent water in the hydraulic jack from adding the... Thank you, Reki. Okay. Dude, where... Sorry, what? What is going on in this question? Okay. I see. This has hydraulic fluid. This also has water. And we have all these dimensions that's going on. Oh, man. Okay. And then the average density of the platform in the cylinder is that. Okay, so this is like row of the metal. I'll just say like row metal. Equal to like 1,500. And then I think for water... I think row water is equal to 997 kilograms per meter cubed. Is that correct? Pretty sure that's right. My audio's breaking up? Uh-oh. Really? Should be fine. Okay. Good. Oh, it's fine. Just have you said that. Okay. Thank you, Jeff. Keep me updated. This is a very experimental stream today with all the different settings. Okay. If the water levels in the reservoir and at the bottom of the sliding weight are at the same height. Oh, okay. So they're saying that this height is equal to this height. Great. Okay. Determine the magnitude and the magnitude of the sliding weight. Okay, cool. Interesting. So I think we have to figure out what all the different forces are, right? Yeah, okay. So this is like rho GH equals rho GH. So, yeah. Pressure on the left. And wait, did they tell me about... Platform is 10 centimeters in diameter. You guys use 1,000? Okay, that's cool. We can use 1,000. That's fine. That's easier. Yeah, anybody else tell me if my audio sounds like it's breaking up on the stream. It looks okay to me so far. Raven Violet's like, meow, meow, meow. What's up? Okay. Pressure left has to equal pressure on the right. Correct? I feel like I need to know the... Oh, but I do know the diameter of this. Oh, perfect. Okay, that's exactly what I needed. Yeah, I was like, wait, I need the diameter. I need to know the dimensions of this thing, right? Okay, so on the left... So we need the pressure here to also equal the same pressure here. Isn't that called... What do they call that? The common datum? Job? That's okay. Yeah. Okay, now I remember how this works. Okay, I want this. I think I want this height. Yeah. Yes, okay. So, this... Oh, here. So, let's do pressure on the right first. Pressure on the right is going to be rho of the water, G, times the height. In that case, that's 11... plus 5. So that's me 16 meters. So that's the pressure due to the height of the water column. And then we're going to also say plus pressure is force times area. So that's going to be the sliding weight times pi r squared. PG-16. We came up with a new rating system. Okay. That's pressure on the right. You have 16 meters of water, which is pushing down to here. And then you also have some amount of weight, force, on some area that's also pushing down, right? I can do some Calc 3. Yeah, this is a fluid. So that's pressure on the right. Okay, so let's look at pressure on the left. This is where things get a little bit weird, right? Oh, yeah, this is fluid mechanics. Yeah, I'm pretty sure. Okay, so let's look at the pressure on the left. Boom, boom, boom. Now, here's the interesting thing. Do I count just this column of water? I feel like I just count this column of water. Pushing down on it. So I think that's rho g times, if this is 5 and this is a meter, that's rho g times 5, because the whole thing's 11. Good luck on physics, dude. Yes. Okay, so this is rho times g, rho the water, rho g times 5. So that's the column of water. Technically also plus p atmosphere, though, right? Because this is open to the air. Wait, is this also open to the air? Wait, are they both open to the air? I think they're both open to the air. Can we agree to that? Okay, so P atmosphere on both sides is just going to cancel. That's fine. And then you have this big thing. Oh, thanks, DMs. Thanks for the good lucks. Okay. So rho G5 and then plus the force of all this, which, man. Okay. That's going to be rho of the metal. And then you got to come up with all the volumes. And so, like, that's going to be the volume of the... of whatever, the top. Plus the volume of the column. What's going up, Shifter, dude? Good to see you, bro. What are you playing these days? Okay. Volume of the top is going to equal to pi times r squared, pi times 5 squared times 1. Great. And then volume of the column is going to equal to pi times 0.5 squared times 10. Right? This is pi r squared h. Right? And this thing is 10 meters long. Okay, cool. All right. And then I think we can figure this out, right? And then here, this r right here is pi times, what was that? 0.025 squared? Yeah? No, this, I do math. I do math and physics, dude. I do it all. Whatever you want. How are circles involved? Okay, yeah, because this thing right here is technically a cylinder, okay? And you have to do the surface area of the cylinder times, like, the depth of that cylinder. Yeah, exactly. Yeah. It's a volume cylinder. This here comes from pressure is equal to force times area. Or wait, force over area. Sorry, my bad. Yeah. So sorry, this should be divided by this. Yeah. Got it. No, a cylinder is very similar to that of a circle. Yeah, no, the volume of a cylinder, dm's greater, is pi r squared, because that's the circular part at the bottom, times the height of how long it is. And thanks for reminding me I have PTSD. Yeah, this is giving me kind of PTSD too, honestly. And I didn't even take engineering. My PhD's in physics. Okay, well, let's just do it. Okay, so 1,000 times 9.8 times 5 plus 1,500 times pi, and then that's going to be 25 plus 0.25, right? Because that's going to be 5 squared, that's going to be 0.5 squared. Oh, wait, it's 0.25 times 10. Okay, so times 10 is just going to make it 2.5, right? Oh, so this is just 27.5. Oh. Okay, cool. And then that's equal to 1,000 times 9.8 times 16 plus the weight over pi times 0.025 squared. All right. I think at this point we just need a calculator, right? Let me go back to it. Where is my calculator? Where'd you go, calculator? Oh, that's my silver one. Oh, the silver one. I can definitely do chemistry. Yeah, submit a question. I'll do it. I'll do it on the stream here. Okay, let's get some numbers. Can I do solid mechanics? Yeah, probably. Okay. He does. I do math and science. I do all the things. Okay, so let's do 1,000 times 9.8 times 5 plus 1,500 times pi times 27.5. This is fluids. Oh, you just realized you have homework? Oh no, dude. Minus 1,000 times 9.8 times 16. Okay. And then we're going to multiply that by pi. Yeah, I look and sound way different. Yeah, well, I've been streaming for probably 4.5 years. Probably 5, actually, at this point. A lot will change in 5 years. I'm curious, like, what you think the differences are. Do I sound, like, more tired? I feel more tired. That's just also the world. Okay, cool. So, I get that the weight is equal to 42.8 newtons. Okay, is that okay? You sound older and more tired. Yeah, yeah, that's just getting older. It just happens. Yeah. Okay. Cool. 42.8 newtons. That's what I get for this. Do we know if that's right? Random dude on... And I'm going to use 9.8. 9.81 doesn't make a difference. Chill. Zesty. Yeah, I definitely had a lot more excitement for life like 4 years ago. It does tend to wear you down. Youth is real. It's okay. Alright. A maintenance device is to be placed on top of the submerged platform temporarily. The device will exert a netward down force of 10 kilonewtons on the platform. The net force being the difference between the weight and the buoyancy forces associated with the device. Determine the new locations of the submerged platform and the sliding weight. Damn. That's a lot. A net force, the weight and the buoyancy forces. Okay, so I assume we don't really care about the buoyancy. I actually didn't even account for any of the buoyancy here. Yeah. But I think by not including the water that the thing is taking up, you're kind of negating the buoyancy force. I believe so, right? Sliding weight was 1.06 kilonewtons. Uh-oh. Well, that's not correct. What did I do wrong then? 1.06 kilonewtons. I agree that 42.8 newtons is very low. But let's see. 1,000, 9.8. I'm pretty sure I did this. 1,000, 9.8. 16. Right, yeah. 1,000, 9.8. 5. And then that. Pi 0.5. Let me see. Maybe you do have to account for the water weight. Let me see it. When in doubt, no, I'm going to throw it through ChatGPT. I could throw it through Chegg. I stopped paying for Chegg, though, honestly, because I was using just ChatGPT for everything. And I was like, why am I still paying for Chegg? Although Chegg does come with, like, Tinder Gold, apparently. And, like, HBO and stuff. How do you submit questions? That website down there, actualofficehours.com. That's how you submit questions. Bum, 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 bum. Chegg is greedy as fuck. I agree. Yeah, they charge a lot, and they really didn't account for the AI thing coming in, and so yeah, that got kind of screwed. He says account for area differential at the base of the cylinder. All of that weight is to be canceled by the fluid under it. Oh, see, well, this is now getting too complicated for me, random user, dude. What? You're saying I need to also account for this pushing up on this?
No.
Oh man, really? I mean, I guess so, but oh. Yeah, I get it. It's a fluid, but really? Yeah, it's just annoying fluid math. Okay, let's see. ChatGPT apparently got your 1 kilonewton, so let's see what they did. I want to see like how. Oh, the fluid under the cylinder. Sorry, you talking about this fluid? I don't think I really care about that fluid though. No, because I'm finding the pressure here. which means all of this is like null. I don't really care about that. Right? Sorry, let's see. Not there. Here it is. Okay. Supporting cylinder, yeah, was pi. Okay, so I got 27.5. I don't know why they got 26. Wait, one sec. Wait, what? The cylinder is half a meter in radii, right? Yeah, one sec. There, get rid of this. Net downward load on the big piston is the weight of them minus the buoyancy. Oh, interesting. But we don't count the weight of the water above. I don't know if I did yours yet, River. No, this is only the second question. Sorry, wait a minute. I get this, but wait, these are both things. Net downward load on the big piston is that minus the buoyancy. Okay. I agree with this. Rho average minus rho weight over G times GV. The platform diameter is 10, so yeah, that's... Okay, so they do D squared... Wait. It's R over 2 squared. Pi. Yeah, wait. 0.5. They do post some serious engineering questions. Yeah, it's okay, though. Wait, and it's not 5... Oh, I see. They don't count this. Oh, fascinating. I see. Oh, man. Actualofficehours.com. Go down there and submit it. Yeah. I see. Hydraulic jack areas. Big piston. Small. Well, I did this correctly at least. Yeah. Area ratio. With equal... See, this is the funny thing about engineering, dude. Engineering uses all these, like, cute little shortcuts. They're like, oh, well, if the fluid heights are equal, then it's just, what is it? Yeah, FA equals FA. Yeah, okay. No, it's totally fine. No, you can definitely ask me these types of questions, but yeah, I'm going to pass on this, just because it's taking up a lot of time. I appreciate you asking it. It's cool. But, yeah, let me get through a little bit more of the queue. It's just, yeah. Engineering question. This is why I honestly don't like engineering, because it's so tedious. There's all these little things. You're stuck on B. Yeah, I understand what's going to happen with B. It's because the height of the fluids are going to change. So I'm going to help you out and just say like solve part B. I'm gonna at least let you have my expensive ChatGPT to see what it gets for an answer. Exactly, Glizzy. There's so many components. There's so many like little things, and then if you forget one thing, it just screws up the whole question. It's just yeah. Engineering to me it's not fun. It's tedious. Okay. Here apparently is the results for this one. Random dude on Twitch. I will share this with you. So here's what I'll do. I'm gonna post this link of like what it did. I'm guessing more than anything that this has already been done on Chegg, and it's probably just scraping it from Chegg, which is probably right. So here, this was random. Whoa, wait, what was your username? Sorry. This was Logan94. It looks right. Okay, cool. So here, I'm gonna give you the screenshot for it. Just in the essence of time. So Logan94. I'm gonna give you that. And then here I'll include what we did here, so you can kind of see what I was doing. But yeah, I need to also include the buoyancy of the metal. Yeah. Okay, cool. Good question regardless. I mean, I had fun going through it. I always appreciate people submitting things that are outside my comfort zone because it's fun to see what my limits are. It's fun to see how much I can do because a lot of the engineering can be done with physics. It's literally based on physics, but it's just like how much physics do I want to apply to it? Yeah, don't let it discourage you. Totally not. No. It happens. It's okay. All right. Let me see. River, what's your question? River submitted one. Okay, River is asking about the chain rule. I can definitely give, chain rule. Totally give you explanations about the chain rule. Yeah. Here's like a quick and dirty explanation about the chain rule. So let's say, for instance, you have a function. Let's say like f of x is equal to, I don't know, like x to the third plus 5x squared to the third. That tracks. Yeah, what's up, Zach?
That's dope.
We were just talking about AI on your stream, right, Zach? Shout out to Zach. Shout out Zach, dude. Yeah. Yeah, it probably is. Okay, so chain rule. Let's say, for instance, you wanted to take the derivative of this. So let's say I want to say, what is df dx? And that's my question, right? A couple ways you could do that, right? I could take this and I could expand it, right? So I could do, this times this times this. But honestly, this like kind of sucks. Because you have to like foil between like all of this, and it's just an absolute nightmare. You just don't want to do it. It's painful.
And I just said, just shut up and let me enjoy this pain.
It's painful, so you don't want to do that. Okay. So the reason why that would technically work is because eventually when you just have like, 6x to the 9th plus, or I guess it would be, 6x to the 9th plus like 3x to the 7th. Taking derivatives here is easy because you just move this out front, multiply, and then you drop the power by 1. The issue is that getting this expanded out becomes increasingly more difficult as you go to higher exponents. Higher and higher exponents, okay? So a better way to do this is to say, hey, wait a minute. I know what the derivative of something to the third is, right? I know what that is. That's the same thing as pulling the exponent down, 3 times that something, and then moving the exponent down 1 to the second. Okay? However, everything comes with a price, and because we did this trick of, again, ignoring all of this and just calling it, like, big red box, like, taking the derivative of box to the third is 3 times box to the second, you then need to also do the derivative of whatever was in the box. Okay? So you also need to do this derivative. Okay? In that case, derivative of what's in the box is the derivative of x to the third plus 5x squared. That's just going to be a nice simple power rule. That's 3x squared plus 10x to the first. Okay? And then you can kind of remove and be like, okay, well, what was this box? Well, box. Oh, we got rid of the box. Wait, where'd the stuff from the box go? Yeah. Be like, okay. Now I know what was in the box anyways. And so my final answer becomes 3 x to the third plus 5x squared times this. What's up, clickbait? What's up, smart people? Yeah, so if you submit a question on face change, I'll do it. And what really happened here, I mean, this is the formal definition they tell you. They say that, like, df dx is equal, well, here. Let's do it this way, sorry. Df dx, let me move this over. Df dx is equal to df du times du dx. This is the formal definition of the chain rule. And the reason for that is that this, right, this d's they kind of cancel. So you eventually get df over dx. We're doing the chain rule. The df du part came in play when we said, okay, instead of saying f of x is equal to x to the third plus 5x squared to the third, I'm going to rewrite this as f of u, where now this is equal to u to the third, and u is equal to x to the third plus 5x squared. Okay? So now df du is equal to 3u squared. Okay? But then you need to multiply that also by what du dx is. All right? And if this is u, du dx ends up being 3x squared plus 5x. Okay, so now you have your thing. You're like, oh, cool. All right, so df dx equals 3u squared times this, right? And then u was that, so it's 3 times 3x squared plus 5x. Or, no, sorry, u was x to the third plus 5x. Sorry, my bad. This was u. 3 times x to the third plus 5x squared to the second power times 3x squared plus 5x. 10x. Wait, who's saying 10x? Oh, yeah, sorry. Thank you, guys. Yeah, I'm screwing that up. Sorry. Yep. I'm running with a pencil. Sorry. This is 10x. Thank you. I make mistakes too. Okay, cool. Yes. There you go. Why is it lagging? Shouldn't be lagging. Upload speed's pretty decent. There's always going to be a little bit of a delay. That's just how a live stream works for you guys watching on Twitch. Or sorry, on TikTok. Can you explain the notation? Yeah, okay. So this means take the derivative of f, but do it with respect to x. So you'll learn later when you do partial derivatives that you can have different variables in a function. So for instance, you could have a function f of xy, which let's say is equal to like, I don't know, like 3x squared plus 2y. And then if you wanted to do partial f, partial x, this says take the derivative of this thing, right? Take the derivative of f, but only do it in terms of x things that are changing. So in that case, y is not an x, so we consider it a constant. So we don't care about how it changes, and so we consider the change of that to be 0. So df dx in this case would be equal to 6x to the first. Df dy would be equal to just 2, just 2. Because 2y to the 1 then becomes 1 times 2y to the 0. Yeah. So that's the notation. When we write this out, it's like, okay, cool. This is what you're taking the derivative of, and then this is the variable you're taking with respect to. Delay. Yeah, I know. Wow, we got like 6 or 7 people up in Discord, though. Yeah. Come to Discord if you don't want any of the lag. There's no lag on Discord. Okay. That makes sense? Cool. Nice. Great. Thanks, River. Good question. Teach, what's up, dude?
Well done.
Okay, this was River. I'm gonna put this in our Discord. Let's drop this in. What's up, Swiss? And then also, yeah, if I have a video on this, River, if you want to see it, I've done it on YouTube before. I always say it on purpose. Go calculus. Yeah, we love calculus. Calculus is one of my favorite math classes to teach. Yeah, if you go here to the YouTube that we have, and if you type in chain rule, I have a video that is like really nice and animated on it. Yeah, it's like right here. The part 1 of this one has 113,000 views on it. It's a very popular video. Yeah, 8 people on the stage, amazing. Yeah, so go check this out. It's a really good video I did on like how the chain rule works, and it has like a lot of fun like animations and stuff. And I kind of explain like with the boxes and like how things move and stuff. Yeah. So go check that out. I'm baffled you don't get millions of views. I mean, 100,000 isn't bad. It's not a million. I think overall the channel has like 1.4 million. But you know, we're working. YouTube is a very slow game. You have to like be consistent and be totally okay with getting like fucking nobody watching your shit for like 5 years. And then eventually it hits, and then like you can do stuff. All right. Nice, good job, River. Adicha, oh, you redeemed me first. Okay, yeah, technically yes. That is a reward on my Twitch. I will do your question first. So yeah, we have a pretty long queue here, but if you're on my Twitch and you like spend channel points, I will go do your question first. So let's go do that. Again, if you want to see how to submit questions, actualofficehours.com has it. You can just drop a screenshot in, blah, blah, blah. We have links to our Discord. If you want to watch it on Twitch, it's a little bit easier in the horizontal format. And then there's also a calendar here that tells you every time we stream. The queue is now at 13. Although some of these are doubled, so I might like... Wait, this is Adrian. Wait, where is yours? Addy. Okay, there you go. Factor completely. Okay, so this one will not take very much time. Addy says, this is sort of review. The one that has a C is easy, but... Sorry. The one that has a C is easy, but this one's confusing. Okay, what's confusing about this? Sorry, what? Oh, there's a third term. Well, okay, here. Yeah. So, let me make this harder. I can make it harder. Let's say, for instance, you have 48x squared y to the third minus, let's come with another number. 32x y to the fourth. Okay? Let's say I ask you to factor this one. Do you know how to factor this? By 16, probably. Yeah, okay. So that's a good thing, yeah. So I always check on the number. This is called the greatest common factor. I'm like, what goes into both these things? I'm like, well, a 16 goes into these, right? So you can pull a 16 out. That's great. And then what do you do next? Right, so then you look at the other term, which is the x's, and you see what's the biggest common thing between them. In this case, it's x to the first, right? It's not x squared, because this only has an x to the 1. Good. And then finally, right, we look at the last thing, the y to the third. And then, good, right? And then y to the third is now the smallest y exponent. So I'm going to pull out a y to the third. Great. Awesome. Okay, then what's left here? Like, what goes back? This is always a good question. I'm trying to figure out. Three, because 16, exactly, right? Yep, good. So always think about, like, this times what gets me back to here. So that's going to be 3. And then what else? X to the 1, good, because x to the 1 times x to the 1 gets me my x squared. So you can just leave this as, like, x. Or we'll leave it as x1 for now. Right. And then that's it. Yeah, exactly, because the y to the third is already going to get me the y to the third. Yep. Good. Owen might have it, yeah. Well, it's a party in the Discord stage, jeez. Good. 2. 16 times 2 is 32. I already have the x to the first, so I don't need that. And then, yes, you just have the y. So, yeah, your final answer is 16x y cubed times 3x minus 2y. And you're done. Nice. Good job, Addy. Yeah, nice. What is a Weiser Strauss sub? Oh, dude, that's intense, bro. What? That's a very intense one. All right, let's clear Addies. Oh, wait, did it get rid of all of them? God damn it. Ugh. All right, one sec. That was Addies. I don't know why the queue cleared itself, but I have everybody else's questions. I'll do them. All right, so we did Rivers. Let me do Logan's. All right, here we go. The fundamental rule of calculus. Yeah, that's another good one. Here we go. Logan. So I keep backups of everything. Okay. Here, Logan. This is Logan's. Says, we know that the gravitational acceleration on the moon is 1/6 of that on Earth. How long does it take a 2.5 kilogram rock to fall 15 meters on the moon? Very good. Kinematics equation, right? So x final equals x initial plus v initial t plus 1/2 at squared. Okay. The final height is 0. The initial height is 15 meters. There's no initial velocity because you're just dropping it. And then it's plus 1/2. Now the acceleration is usually negative 9.8. That's like minus g is what we say. However, in this case, we know that the acceleration is 1/6 that on Earth. So it's going to be negative 9.8 over 6. This is 1/6 the gravity. And then that's going to be t squared. Cool, right? So you can solve for this. So I move that over. I multiply by 2. I can also multiply by 6, I guess, as well, right? So 15 times 2 is 30 times 6 is 180. And so you get 180 is equal to negative 9.8 t squared. Final steps here is take the 180, divide it by 9.8, raise it, and then take it to the 0.5 power square root it. And so you get 4.29 seconds. Okay, cool. Hope you got that, Logan. Great question. Love it. No, you're good, Bobby. Yeah, no. That's a new thing I just added, honestly, to the stream. Yeah, that is the amount of time left in the stream. Just to kind of, like, help people get expectations on, like, when I'm ending. The queue cleared itself for some reason. I think because I accidentally reloaded it, and it was in a post state. I still have everybody's submission, so I'll go through them. But the queue is a little bit longer than one person. It's like 9 right now, but I have it. I can't manually restore it, unfortunately. But okay. Anyways, good job, Logan. Yeah, no, the streams are a lot longer. The streams are like 3 hours. Swiss says, Dr. Gold, what do you do for work? Does your YouTube self-sustain? I will show you my YouTube earnings. Totally. I'll show you them right now. We only just got monetized, actually. In the last 2 weeks. So I've only been able to make money on YouTube in the last 2 weeks here. But yeah, let's see. What's my money at? Right here. Let's see. Can I see? It should show me how much money I've made. No? Or maybe my dashboard. Analytics. There you go. Estimated revenue, $21. So yeah, $21 isn't exactly gonna pay the bills. So no, YouTube does not sustain my my ability to pay rent right now. Awesome, yeah. Thanks, random user. Hey, good luck on your physics exam tomorrow, dude. $21 is more than most. Yeah, no. And believe me, I don't want to, like, you know, like, have people, like, lose all hope. You can definitely make a lot of money with YouTube, but it's a very long thing. We only just got monetized, I think, last week or 2 weeks ago. So, in time, that will build up. But, yeah, to answer the question, I do other things to make money. This is just free because it's a nonprofit and stuff, and we like to be nice. Ninjati, okay. We got some math review questions here. These are fun. Yes. Yeah, bless your soul. With negative 9.8, do you get imaginary numbers? You don't. Sorry, I fucked up here. Sorry, there's a minus sign here. Sorry, when I move that over, that's minus 15, and then times 2 times 6. So, yes, you are correct that... This is another thing in physics. We just kind of ignore minus signs, and we say, well, it should be positive. Like, time shouldn't be negative. So, yes, the rigorous math way to do that is I should have put a minus sign over there. Yeah. All good. So, I'll say minus 180 on the left. No, you're good, Tom Blue. No, I fucked up. That's not your problem. I screwed up. Oh, that is... No, that's U sub. That's U sub, Alistor. That's not Trig sub. That's U sub. Yeah. You just say U is equal to x squared plus 1, and then du is equal to 2x dx. Yeah, that's U sub. Which, okay, this was somebody else's... This is another beautiful example of... Here, I'll show you, like, why this is just easily U sub sometimes. Oh, sorry. Let me give you perms, Alistair. Sorry. There you go. You can swear now, Alistair. There you go. You're okay. Yeah. Let's see. I'm going to do one of these. Or you can tell me if there's a specific one you wanted to help with, but I think this is a really good one. People look at this and they're like... Yeah, no, it's not Trig sub. So, see, here's the trick. And here, let me pull in Alistair's, because... This is also a great example of... I understand why you think it's trig sub. Because in general, anytime you see, like, square root of, like, x squared in this, you usually are going to do, like, a 1 plus tangent squared or a 1 plus secant squared or something. But here's the first thing you should always look for when doing integrals. Try to see if whatever that nasty shit is you don't like, if the derivative of it shows up somewhere else. In this case, yeah, the derivative of x squared plus 1 is 2x, which is basically this thing on the outside. Yes, GWC, yours is. The queue got cleared, but I see yours. So in this case, you would just say, okay, cool. Well, let u equal x squared plus 1, then du is just equal to 2 dx. And then you can rewrite this, or sorry, 2x dx. Sorry, my bad. 2x dx. So that means that dx is equal to du over 2x. And then watch what happens. So integral of x, square root of u, but now dx is du over 2x. The x's cancel. Right? This cancels with this. And you're just left with the integral of 1/2 square root of u du. This is an easy integral to do. Right? This is just u to the 3/2 2/3. Right? Plus c. Don't forget the plus c. And then there's a 1/2 outside. And then you just replace u back with what you have. So you end up getting 1/3, what was that? X squared plus 1 to the 3/2. And then you're done. Plus c. Do you see that? Do you see how that's a lot easier to do? Because you just have to recognize that the derivative of it shows up somewhere else. Yeah? Yeah. I understand why you think it's trig sub. This is another beautiful example, right? This looks like an absolute mess. Like, I really don't want to deal with this. It just, like, looks like a huge pile of shit. Because I have cosine 2x and then ln of a trig function, ln of sine 2x.
One big pile of shit.
Right? The nice thing here, though, is that, oh, I recognize that the derivative of sine of 2x, shows up right here. So I'm going to say, okay, let me call this thing u. Let's just say let u equal to sine of 2x. Here, let me move all this over. U is sine of 2x, so then du is equal to cosine of 2x, but this is also a chain rule because you have to take the derivative of what's inside. So maybe River, if you see, this is really similar to what I did when I taught you the chain rule. I do not know what the derivative of the sine of 2x is. I know what the derivative of sine is. It's cosine of whatever that thing is. But because I did that, like, you know, hand wavy, like I don't want to look at what's in the inside, you then have to take the derivative of what's inside, and the derivative of 2x is just 2. So this becomes 2 cosine 2x, and then dx. So now when I solve for this, that tells me that du over 2. Well, actually, no. What do I want to do? Yeah, this is what, technically I want to put all this under here. There we go. Du over 2 cosine 2x is equal to dx. So now substitute back in, and you have integral cosine 2x, ln of u, and then dx is now du over 2 cosine 2x. Well, look at here. These things are going to cancel. Gone, gone. And now I just have 1/2 integral of ln of u du. Okay? This is... integral of ln of u, I think, is a special one you just have to know. Is this from you, X for math? Was this your question? Integration by parts. I don't think we want to do integration by parts. I think I just need the integration. There is just a integral of ln of x. This is one. I think you just have to know this one. Oh, you can integrate by parts. Oh, that's super cool. Actually, yeah, we're gonna do it. Let's do it. Thank you, Dom. Yeah, let's do it. Integrate by parts. What's up, Mathematic Fanatic? Yes. Yeah, let's show how you integrate by parts. This is so fun, actually. You pretend this is a, like, times 1, right? So I say that, oh, well, now I have u's and v's again. Okay, fuck. All right, let's call this, like, a. You can always change the variables midway through, as long as you change all of them. So I'm going to say that u is equal to ln of a. Then that means du is equal to 1 over a, dA. And then I'm going to say that dv is equal to 1. So that means v is equal to a. Or, sorry, dv is equal to 1 dA. Yeah. This is one of your test problems? Yeah, this is kind of fun. Okay, so then integration by parts says it's equal to uv minus integral of v du. I know my v's and my u's look the same. So uv would be a ln of a minus the integral of a 1 over a dA. Oh, this is cool. This goes away. Oh, so now it's just integral dA. Integral dA is just a. So you get a ln of a minus 1. Is that right? Okay. So it's 1/2 and then a, but a is also u, and u is sine 2x. So we're going to say 1/2 sine 2x, and then it's ln of sine 2x minus 1. David lost my account. Did I not give you perms? You need perms too? Yeah, one sec. There you go. You can swear as well. DMs. There you go. Plus C. Oh, dude, I almost fucked up. Okay. I think that's right. Okay. And then let's see. That was on... Someone gave me that question. I was like, I think it had an answer on it as well. Where was it? Yeah. Okay, let's see. This was apparently the result we were supposed to get. Looks pretty similar. Look, sine 2x over 2. Right, that's the 1/2. ln sine 2x minus sine 2x over 2. Nice. Good job. Nice. That was a fun one, Ninjati. That was cool. Ninjavi. Nice. Yeah, thanks for y'all in the chat reminding me that, yeah, you can actually just do integration by parts for ln of a. I forgot about that one. That's actually really cool. Here, I'll fix it for you too. All right, there you go. There you go. You guys are okay. All right. Let's do the next one. We're almost at an hour left. We're still doing good. Next question came from, let me see, GWC. I see you, dude. Let me post this in. Integral of x to the x. Is that another one where I need to know it? Okay, here we go. GWC. All right, this question is free response. Show your work. Suggested time 25 minutes. We'll see if we can do it faster. Okay. So block A is sliding. I guess block B is stationary. At time t2, it collides with it. So key thing here is this is elastic. Sorry, let me move this a little bit. Sorry, this is elastic. Elastic tells me that the change in kinetic energy will be equal to 0, right? If something's elastic, there's no loss in kinetic energy. The right side of block B reaches an ideal horizontal spring. Okay. And then, okay. It's initially at rest. Do we know if block A stops? Sorry. Oh, and block A comes to rest. Oh, very cool. Okay, so this collides. But now V is equal to 0. Yeah, what's up, Doc? Oh, thank you for the hearts. Okay, and then it compresses, and then it's also at rest. Okay, a lot of stuff going on here. Indicate whether the linear momentum of the two-block system is either constant or not constant during the time interval from t1 to immediately before t3, and explain why. Momentum is almost always conserved, unless you have non-conservative forces. So I would say, yeah. Yeah, also in collisions, momentum is conserved. When you have this happening, so when you have the spring acting on it, now you don't have conservation of momentum. Right? If you have external forces, momentum is not conserved. So, but up to T3, block B hasn't started pushing the spring in yet. So GWC, I would say that yes. I would say there's no external forces. If you have no external forces, momentum's always conserved. Okay. Indicate whether the mechanical energy is constant from T1 to immediately before T3. It is as well, because it was an elastic collision. Elastic collision means what counts as an external force? Anything, honestly. So an external force can be like someone pushing on something. It could be like tension in a spring. It could be like tension in a rope. Also, it could be the force of gravity. So if you want to notice something here, GWC, momentum is not conserved when something's falling, right? Consider, right, you have a block here. And let's say it has mass mv is equal to 0. Let's say 0 momentum. And then you let it fall, right? Well, now it's obviously going to have some velocity downwards. Do you see how the momentum changes? Because there's an external force. So yeah, gravity is an external force. Any sort of tension, anything in the spring, external force, that does not conserve momentum. In terms of energy, so kinetic energy is only conserved during collisions if they're elastic. If they're inelastic, then the only thing is conserved is momentum. What app do I use? I just use a Wacom. It's a Wacom. And then I use a website called Group World. This is physics. Yes, physics, Tom Blues. All right. GWC, does that make sense? I appreciate the questions. Like, yeah, please ask me along the way. I mean, it's funny that they say that this thing is going to take 25 minutes. I mean, I think I can do this in 5. I thought they were going to have us solve for some shit, but I guess they didn't give us any numbers or anything. It's really cool to like solve for like how far the thing compresses and stuff if they gave you numbers. Okay, indicate whether the linear momentum of the 2-block spring system is constant or not constant during the interval from T3 to T4. Exactly. Okay. So from T3 to T4, okay, now block B is fighting the spring. So block B experiences a force. And because there are external forces now, the momentum is not conserved. So you can say no, and you can say there's an external force from the spring. Okay, and then indicate whether the mechanical energy of the 2-block system is constant or not constant during the time T3 to T4. So, yes. Well, does mechanical energy include the spring potential energy? Is that also mechanical? I always get confused, like, which... I hate the word mechanical energy. Does mechanical energy include spring potential? I forget if it does. Yes. Okay, wait. Mechanical is the sum of its kinetic and potential. Okay. So, yes. The spring potential energy is a form of the mechanical energy as well. Okay. It's always these, like, definitions and stuff. Yeah. I was too, E-Raven. Yeah, like some 1/2 kx squared or something. Yeah. So this is also yes. And you can say, because... the spring force is conservative. And here's what we mean by conservative forces, okay? It means that any, like, force, any, like, kinetic energy that gets put into potential energy can be easily transferred back. So, for instance, if you're moving really fast and there's a spring that isn't compressed, but then as you move into the spring starts to compress, that transferred kinetic energy into potential energy. But I can just as easily convert that potential energy back into kinetic energy by just letting the spring bounce back. So that's what a conservative force is. Friction is like not... The force is Republican. Yeah, so no, friction is a liberal force. Friction is non-conservative. Because the energy you lose to friction can't be returned to you, right? If you're going down a hill and you start slowing down because the friction is like fighting you, that friction gets lost as heat. You can't grab that heat and like turn it back into like kinetic energy to get you moving again. So, yeah. That's the difference between, like, conservative and non-conservative forces. And friction and things, yeah? Cool. Okay. Does that all make sense to you, GWC? This is a cool question. I really like this one. Has a lot of really fun situations. You have to think about things, like, kind of theoretically. Brian says, please do my statics question. I will get to it. Don't worry. If I have time. Look, there is a timer. The timer says, like, 52 minutes. But okay, cool. Good job, GWC.
Well done. Well done.
Dude, what's happening in my Discord chat? What are you guys up to? I haven't had time to like look at it. The doomsday clock. Wait, yeah, what did Sebastian... Sorry, this is off topic, but I think it's weird. A problem in my math homework today had a person losing weight for the loser competition. Sounds AI generated, but it's from an AP book? Oh, that's kind of interesting. Yeah, maybe Trump's getting a hold on the AP curriculum, dude. Saying like, yo, big fat losers or something, or you're not wonderful, incredible, whatever words. He uses like fucking 4th grade like level intelligence words. Okay, this was GWC. Okay. Where did my TikTok chat go? When is the schedule for going live? Yeah, wait 1 sec. My Twitch chat went. My TikTok chat went down. 1 sec. Let me respond to GWC. Sorry. What do they mean if it's conserved? Okay, I hope I answered that. Yeah. Conserved again means that the energy could be converted back into the form that it came from. Oh, I see. I have to drag to fit the puzzle. Wait 1 sec. Okay, there we go. There we go. Man, what? I see. Let's go back here. Okay. And here, let me activate the source. Tick toward sounds like a phrase made up by incels. Yeah, tick toward. Or like rumble tick. Rumble twitch. Rumbitch. I don't know, dude. 1 sec. Get. Okay, there you go. It's figuring it out. Oh, I just had it working. Man. 1 sec. There you go. Okay, I think it works now. Yes, check the website, Aiden. Yeah, it's there. Okay, let me figure out the next question we're going over. That was GWC. Dun, 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 dun. Nicole asking about banked corners. Cool. I like this. This is good. This is another physics question. Dun, 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 dun. I'm working on automating, animating algebra solving, and it's very hard. Have you ever used Manum, Mathematic Fanatic? You can get ChatGPT to write Manum code for you. That's what I do for a lot of my math animation for algebra. It's like decent. It at least like looks kind of nice. But if you're trying to like show like this moves to this or this moves to this, yeah, that stuff you have to kind of do by hand, and that takes me a while. But if you have some way to automate it, that'd be super dope. I would definitely be interested in that. Again, send me a DM if you want, because I've had a couple other streamers reach out to me actually about this queue system that I coded, or really ChatGPT coded. I just kind of vibe coded it. So I'm gonna look into like a way at making it so that it's very easy for other people to use it as well, but have their own like separate queue. We'll see if I can get ChatGPT to vibe code like multiple queues. I think I can get it to work. I have a decent enough knowledge at coding that I can figure out what I need it to do. It's just all the syntax. Like I don't know PHP. I know like C++ and Python, but like PHP, I'm like, ugh. I just don't want to. I hate web coding languages. Okay, let's see. Why are racetracks often banked at the corners? What would happen if they were not? Okay, they're often banked at corners. Yeah, here's the reason. To allow higher speeds without falling or without sliding off, I would say. Sliding off. What would happen if they were not? Well, because they would slide off. Okay, cool. And if you want an explanation for why this is, yeah, let's look. Okay. So, let's say, for instance, I was like doing like kind of like a top view, yeah. Let's say you're moving around in a circle, right? Let's say you're moving around this way. Okay. In doing so, you have what's called a centripetal acceleration, because your velocity is changing directions. You can be going around at the same like 60 miles per hour. You can be going around at the same speed, but because velocity has direction and your direction changes from like here to here to here to here and whatnot, you technically have an acceleration, because acceleration is change in velocity over change in time. That centripetal acceleration is what friction takes care of so that you keep moving around in a circle and you don't just like fly off. Right? If you don't have, if there was no friction on your tires or anything, you would just like fly over here and like hit into the wall.
No.
That would be bad, right? So this is what I can say is like the top view. Let's say top view. Okay, and then let's look at like some side views. And let's say, for instance, that you're on a flat track. Okay, so if you're on a flat track, and then I always like to try to describe, like, when I say like side view, so for instance, this is on the top, and then what we're doing is we're looking at it this way. Like, do you see how like I'm like kind of like putting my face down and like looking at it from the side? So maybe sometimes this helps with people to see. It's kind of 3D-ish. Okay. Okay. So now this is the car, and it's moving around this way, right? It's going like this. Okay. You can draw force diagrams for this. This ends up having force of gravity pulling down. You have the force of friction pulling into the left. And then you have the normal force, okay? It's kind of weird when people see the force of friction pulling to the left. The reason for that is if you were going around and you didn't have any friction, you would just slide off, right? You wouldn't keep going in a circle. You would deviate from the circular path. So friction is what keeps you moving like towards the center as you go around in a circle. And this, of course, is equal to mu s Fn, okay? Which is equal to, and since Fn and Fg are the same, this ends up equaling mu s Fg, okay? And this has to also equal the sum of the forces in the x direction, which is equal to the mass times acceleration in the x direction, which is mass times centripetal acceleration, which is mv squared over r. So this is what happens when it's to the side. It does. No, you're absolutely correct, Tom. It does act to the opposite direction you're going. So, but here's the thing. If I'm in a car, right, and I'm going this way, right, the car wants to keep going straight. Friction pulls it back in such that it moves around in a circle. Okay? It's your tires. Your tires are what, because if we look at it from the side, right, if you kept going straight from a side view, you would like technically move to the right because now you're no longer on the circular path. Yeah, you see it? Yeah. It's a common thing, dude. Yeah, totally. Okay, but then look at like a side view. Let's say like you had a banked track. I did explain this in a short. I did, yeah. I have a really good short on this too. If you look up like centripetal motion on my YouTube, I have a really good animation that a bunch of Ukrainians made for me at one point. It was really cool. Okay, but if it's on a banked track, so this is interesting. So in this case, it was on a roller. Yeah, it was a roller coaster. Yeah. You have the same box here. How should you understand kinematics equations? Kinematics for me is all about figuring out what variables you know, what variables you don't know, and then picking the right equation that has the right things you know and the right things you don't know. I have a video on that as well, if you want to check. I really like centripetal horses. We have a connection. Centripetal horses? Are you a centripetal horse whisperer? Oh, he says where? Okay, yeah. Let me show you real quick. Because I know some people are watching from TikTok. Yeah, if you go to my TikTok profile, and then if you go to, let's see if the video wants to load. It is not this. Here, how to use not Newton's law. Sorry. Not how to solve friction. Here, how to solve 1D projectile motion in physics. This video right here will explain everything, which is like my strat for how you do kinematics equations. So yeah, take a look at it. It's pretty good. Okay, but back to the banked track. Okay, so if something is banked, this is actually kind of cool. Gravity, right, points straight down. Okay, You also have a normal force pointing this way, okay? And then you still have some sort of centripetal acceleration pointing here. But here's the cool thing, is that if we look at this normal force, you have two components to it. You have a component now, this is like Fn in the x direction. This helps keep you moving towards the center. So normal force always points normal to the surface you're on. So if you're on a flat surface, normal force just points straight up. If you're on a banked surface, the normal force points 90 degrees to that, and it has components that are up and to the left, like towards the center of your rotation. So now friction doesn't have to work as hard to keep you on the track, because you have the normal force that's also kind of trying to help you move in towards the track. You have an exam on this? Nice. Yeah. I have a whole video on centripetal motion and stuff. Yeah. Go check it out. It's there on my homepage. I think it just says centripetal motion. And then in addition, right, I think we figure out, right, if this is like theta, you end up figuring that like Fn is equal to, what is that? mg cosine theta? Yeah, mg cosine theta. Okay. So then, it's actually funny, if you're not moving like fast enough, you actually fall down the ramp. Friction can either like keep you up, or it can prevent you from like falling off. It works both ways. It depends how fast you're like moving around in the circle. But yeah, the force of friction, you end up getting this. You get, because then, friction points in this direction to stop you from moving off. So you get Fs, correct me if I'm wrong, I think that's like sine theta. Yeah, anyways, it's complicated. I don't want to draw out all the you don't need it for this question. I think the main thing you just say is that the normal force has an x component and it helps you keep moving towards the center. Yeah. So, good question. The square root of tangent of x, Alistor? What? Why would I do that? Is that a hard one? Y'all trolling me? Alright, this was Nicole's question. So, Nicole, we're going to add it to the Discord for you. Stream hasn't gone down today. I'm kind of happy. So here, Nicole. Lagrange multipliers. Oh man, I have done questions on those. They are kind of a bitch sometimes. We keep derailing from math every once in a while. We do. Dr. Gold, what's your opinion on having long hair? I have had long hair at various points in my life. I think do whatever you want. Long hair can be cool, for sure. Okay. Clickbait's asking me to normalize a wave function. Here, I'm going to normalize a wave function for you. That's what I'll do. I'll do part A of this clickbait. Let me see if I know how to do this. Okay. What's up, clickbait? Normalize the wave function. Okay, so I believe that's where psi star psi is equal to 1. Is that correct? Looks like this, I guess, right? So that's the integral from negative infinity to infinity of a e negative x squared over a. Oh, but there is no I in here, so there's no complex conjugate at all. So it's just this times a e to the negative x squared over a. And then this is dx. This is quantum mechanics for those that are wondering what we're doing. We're doing quantum mechanics right here. Okay, so, and this all has to equal to 1. So I get 1 is equal to a squared integral from negative infinity to infinity of of e to the negative 2x squared over a dx. Oh, yuck. Wait, how do you do this? I don't want to integrate this. Wait, what? Fuck. Oh, man. I got the a squared here. Is this not correct? Oh, over a squared. Oh, thank you. Sorry. Yes. Yes. Ugh. This is where I'm struggling too, because this is not an easy integral to do. If there was an x here, which is what the next question is, this one would be easy, right? And for the very same reason that I give them on Sunday. I do them on Sunday, Bobby. It's like my kind of my Sunday chores. I just go through and give out all the points. Yeah, is it a Gaussian? Is it Gaussian? Yeah, because this would not be hard, right? This would be the integral from negative infinity to infinity, and then it would be x e to the negative 2x squared over a squared dx. And then this is a beautiful case of where, like, you're just going to set this equal to u, because then du dx shows up, like, right here, basically. This would be super nice. This is a little tricky. Yeah, someone said, is this a Gaussian integral? Maybe it is. You know, I can ask ChatGPT how to integrate this. Let's just do it. It'll probably say it's something fun. I don't know exactly what the... you'll get everything on Sunday, don't worry. Solve this. I'm having Gaussian integral mentioned. All right, we got 34 minutes left. I think I can get through these. All right, let's let her rip. Let's see. Use an integral calculator. Yeah, I want to see if there's an analytic way to do it. Joel from Sonic Age Science. Oh, that's cool. Joel, do you have a channel that does science on TikTok or something? Wait. Oh, sorry. I have to do the whole thing. Sorry, my bad. I didn't give it the whole thing. Sorry, this is it. Yeah, sorry. Sorry, just normalize. Yeah, let's see if I forget if this is an elementary integral. Oh, okay. There you go. This is apparently the Gaussian integral formula. Do you have GPT Premium? Of course, dude. What? Yeah. Okay. Yeah. Okay, so this is the trick here. Yeah. Negative infinity of e to the negative alpha x squared dx is square root of pi over alpha. So in this case, right, alpha is equal to 2 over a squared, right? So then you get 2 over a squared, but then it could come out as a square root. So, yeah. All right, so this becomes 1 is equal to a squared, a squared, another a, square root of pi over 2. So then, yeah, I can do integrated rate loss for sure. So what? We get 1 over a square root of pi over 2 is equal to a squared. I mean, this kind of sucks. A is equal to, oh man, what is that? Here, I'm gonna leave it in here. I'm gonna leave the a squared in there because that's that to the negative 1/2, and then I'm gonna put it to another negative 1/2. So I'm just gonna say pi a squared over 2 to the negative 1/4. I think that's it, right? Yeah, there you go. That's what they have. Pi a squared. Yeah, exactly. Cool. Nice. Okay, cool. And then, yeah, so that's a Gaussian integral for you, clickbait. And then figuring out the expectation value, you just slam x in there as well. If I have more time, I'll try to do the other ones. Those require like doing operators and stuff, right? I have to like do the momentum operator and stuff. Good starting question though. Cool. Clickbait. All right, let's see what do we got next. This is from DM Scrotter. What's up, DMs? DM Scrotter, DM Scrater, DM Scraper. What does your name mean, dude? I want to see if my Twitch vertical still works. Okay, let's go here. Do you ever do DSP stuff? Oh, like signal processing? Maybe. I could try. Oh, it looks a little... Oh, nice. It actually looks decent on Okay, that's okay. I'm just checking what it looks like on my phone. I think you can have it go back to the Nice. Okay. Cool. I'm vertical. Nice. Point set topology. Oh, man. That would be painful, dude. What? Okay, here we go. The table and graph shown below model the height of a diver above the water in meters x seconds after the diver leaves the board. Determine the average rate of change for the interval 1 to 3 from the representation. Cool. Okay. So average rate of change, DMs. DMS crater. Okay, thank you. DMS crater. Okay, so average rate of change. You can say like ROT. Is just equal to delta Y over delta X. That's average rate of change. So if you wanted to figure out delta Y minus delta X, that's the same thing as Y2 minus Y1 over X2 minus X1. And so if we're going from 0 to 3, right, that's going to be the Y position at the last time, 3. Reinforcing knowledge, totally cool. So that's negative 7.5 minus 7.5 all over 3 minus 0. So this just ends up equaling negative 15 over 3, which is equal to negative 5. Okay, cool. Now you can ask, like, yeah, what does that represent? Okay, because that's representing the secant line, which is different than, for instance, the tangent line, which is the instantaneous rate of change. So, wait, let me use a different color. Let me use, like, yeah, gold. So this right here, going from 0 to 3, this is called the secant line. And that's the average rate of change, which kind of tells you, like, hey, you know, we were going up, we were not going up, we were 0, we were going really far down, then we were going really far down. But on average, this is what happened. That was our average rate of change. These lines right here, if you were to do them like kind of like this is called the instantaneous rate of change. And it's like where you're going at that moment. And that's also equal to the derivative. Or we could say like f prime of x. I think in this case it's f prime of t. So, yeah, that's what they represent. You eventually do something which is called the limit definition of a derivative, where you take the average rate of change from like here to like something that gets closer and closer and closer. And then in the limit that the 2 points that you're trying to find the average rate of change of are really, really close to each other, you get what's called the instantaneous rate of change, which is the derivative. That's where the limit definition of a derivative comes from. I definitely do calc, yeah. I'm sure you maybe seen that. Have you seen, like, for instance, the limit as, I think it's like as h approaches 0 of f of x plus h minus f of x. And then this is technically x plus h minus x. Yeah, this is the definition of a derivative. Because this right here is like y2. This is y1. This is x2. This is x1. And you're just taking the limit as those 2 points, 1 and 2, get really, really, really close to each other. And then that becomes like the derivative. Joel says the limit does not accept the limit does not exist. That is a Mean Girls quote. That is true. Stop trying to make fetch happen, Joel. Transmission line theory. Oh, I don't know about that. Yeah. If you want to see this, DMS creator, again, I'll point you to my YouTube this time. If you go here, and I think it's like limit derivative. No, it's super cool. Here we go. The limit definition of a derivative. Did I not do a whole big video on it? I only did a short one. Okay, here we go. Yeah. Go watch this video. And this shows you, for instance, where the limit definition of a derivative comes from. Because again, they tell you it's... Where is it? There's some like fancy definition they say somewhere. I think I put it here somewhere at some point. Yeah. Yeah, so this is what it looks like. That's the limit definition of a derivative. And then what they do is they take these 2 points A and B, which are separated in X by H. And then they just reduce H down to 0. So you get these points like closer and closer to each other. And as they get closer and closer to each other, you eventually get what's called like the tangent line. It's really cool. Yeah, so go check it out. I have a good video on that one. Okay, cool. Good question. DMS Kratar. Yeah, no, yeah, no, totally, yeah. And if you're, yeah, again, calculus, all this stuff, eventually, in algebra, geometry, pre-calc, trig, whatever, it's all connected. So the more you see it and are familiar with it, even if you're not at it yet, the better you'll understand it when you have to do it. So, yeah, I think I'm more than happy to kind of show the spoilers of, like, what's going to happen as you get closer to it. Okay, let's see this one. Someone gave me a limit question. This is from Adrian. You know some transmission? Yeah. So again, I welcome you guys. Join the Discord if you want. There's the same link down there, actualofficehours.com, that has we're gonna do this question like where you can like submit screenshots. We also have a link here. You can join our Discord and feel free to post things in. We have a whole like channel here called just like homework help. And people are just posting homework questions that they need help with, and then we just post the solutions to them. So if you post one and like someone else joins and they also kind of know the answer, they can answer it as well. You need help with L'Hopital's. All right, cool. We'll do it. We'll do L'Hopital's. I think this is a L'Hopital's rule question. Okay. Limit as x approaches pi from the left. Now, correct me if I'm wrong. Does L'Hopital's require it to be the limit as x approaches infinity? One sec. L'Hospital rules. No, it's just as x approaches a. Okay, cool. It doesn't have to approach infinity. You have to have like indeterminate form though. Yeah. Thank you, mathematic fanatic. It can't approach anything. Cool. Thank you. Okay. Yeah. So try whenever you see a limit like this, just plug in the value and see what happens. So if I plug in this sine of pi over 1 minus the cosine of pi, well, sine of pi is equal to 0. Cosine of pi is equal to -1. Wait, right? No, wait. Yeah, wait, isn't cosine of pi equal to -1? Wait, so this is 1 minus 1? Wait, isn't the answer just 0? Wait, did I fuck this up? I think the one that's weird for this is where like, yeah, wait, what? This is just 0 over 1 minus -1. This is just equal to 0 over 2. Yeah, cool, great. Okay, yeah, this is easy. The answer here is just 0. Okay, but what I think this one wanted to do, sorry. I think they want to do the limit as x approaches 0 of sine of x over 1 minus cosine of x. This would have been sine of 0 over 1 minus cosine of 0. And that would have been 0 over 1 minus 1, which is 0, right? Yeah.
Surprise, motherfucker.
This is bad. This is bad, right? Probably meant to put minus pi, but even minus pi would do the same thing. Yeah. This, I think, is what they wanted. They wanted either to approach 0 or approach 2 pi. Oh, my audio's glitching? Oh, I hope it's not. I hope it's... Yeah. Okay. Oh, it's fine now? It just fucks up every once in a while. Yeah. My PC is, like, trying to... Okay, cool. Okay, but watch. So, 0 over 0 is indeterminate form, and this is where you can do L'Hopital's rule, which says that the limit when you get 0 over 0 is the same limit, the value of that limit is also the same as taking the derivative of the top, taking the derivative of the bottom, and then doing the limit again. So in this case, the top part is sine of x, and the derivative of sine of x is cosine of x. So I'm going to say, okay, cool. So that's the same thing as cosine of x over, and the derivative of this is, derivative of cosine is negative sine, so this becomes 0. Derivative of 1 is 0. Derivative of negative cosine is sine. So you get cosine over sine of x. Cool. Limit as x approaches 0. I think this is also fucked. Or actually, it's not. This is 1 over 0. Oh, okay, cool. So this is either like plus or minus infinity. Depends whether you're coming from the left or from the right. Or wait a minute. Sine is... Wait, sorry. Sine is symmetric around 0. Yeah, no, it actually does matter, right? Yeah. Yes. Yeah. Okay. Cool. Nice. Good question.
Well done.
That was Adrian. Oh, Mathematic Fanatic. Is my dream to completely automate the animation? Yeah, dude, that would be super cool. 100%. I would love to just feed some sort of algorithm, like my script, like what I'm saying, what I'm explaining, and just have it animate my words. That would save me so much time making videos. I thought I could maybe do it with Manum, but it's not good enough yet. Or, like, I don't have enough, like, conditions or, like, little special cases for it. Right? Because I can explain things. I can teach all day. The animating part takes me forever, and I don't have thousands of dollars to pay animators. If I had a budget for animators, this would be done in fucking, like, 5 seconds. I have so many things I would just love to just get animated. Man, I'm not good enough. Heresy. It is, but it needs, like, a lot of, like, guardrails for it to work. You have to be very specific with Man. I'm telling it, like, what it can do and what it can't. Also, like, I think what Mathematic Fanatic is saying is like, sometimes I, like, want things to, like, curve this way or, like, circle around this way or, like, merge this way. Like, I have animation things that I know make more sense to students that Manum doesn't do it exactly the way I want it to. Fanatic says it's extremely non-trivial. Well, I hope it is. Show me. Right, this is Adrian's question. Let me put Adrian's in. This was a good one. Cool. Let's see. Owen has one with shear forces. Oh, man. So, Owen, I'm going to post this one, but just because I have 15 minutes left, I don't think I can do this one in the time period. But I will post it here, so if someone wants to do it later in my Discord, they can. So, it's a cool one. Don't get me wrong. Yo, it's been a while since you helped me do some physics 2 one time. You're a cool guy. Thanks, Yucky. I appreciate being called a cool guy. I've wanted to be cool all my life. Honestly, it's been like a big goal of mine. So I appreciate you for saying that. What's up? What are you doing nowadays in life? What's crack-a-lackin'? Are you still in school? You a big fancy engineer or a college student? All right, this was Owen. Bum, 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 bum. All right, Dom. Ooh. Okay, Dom. I'm a cool guy. Thanks, Blue. Yeah, where'd you go after physics 2? That's what I was wondering. Yeah, where'd you go? Yeah, that's like too much engineering, right? It's too much engineering, Tom. I don't know. I can't. Not when I have that little amount of time left. I have to keep activating the source. Come on. Okay, let's see this one. Integral from 0 to 2/3 of the square root of 4 minus 9x squared. Yeah, this is definitely a trig sub. It's gonna be a trig sub. One sec. Why is this not working? Activate source. That's where can you do this on the TI Inspire? Can you? Yeah, so here's kind of the rules. There's kind of some rules. Trig sub rules. You have someone to show me? Dude, let's get on a call, dude, sometimes. Like, hit me up, bro. Just DM me. Or I'll DM you. I'll give you my phone number, dude. Like, I would love to see what you're doing. So, here you go. This is kind of the thing I want to deal with. Yeah, when you see... Yeah, this is kind of like the cute little thing they always say. Yeah, I don't know if it's algebraic either. Although 2/3 might come out nice. Okay. So here are the rules. Whenever you see in an integral, whenever you see like square root of a squared... Oh, it's okay. No. I know, John, if you added too many, it's okay. I'll do the first one you added or something. So if I have a squared minus x squared in a square root, you want to use this substitution. You want to say x is equal to a sine theta, which you did do here, right? You said, oh, okay, cool. Look, a squared is equal to 4, so a equals 2, x equals a sine theta. Cool. And then that means dx is a cosine theta d theta. Great. Okay. So we put that in here. Okay, so the next step is all you have to do. Yeah, it's okay if I don't get to it. I'm gonna code a new thing on my queue system so that any questions that aren't done automatically get posted somewhere else. So that other people can solve them, or if we have time on the next stream. But I always have like more questions coming in. I need more help. This is where I'm gonna talk. Zach and I are gonna have a conversation tomorrow, and I have some ideas for things. Okay. So this is the integral. So watch this. This is square root, right, of 4 minus 4 sine squared theta. And then we have times 2 cosine theta d theta, right, Dom? I still can't believe it's real. Yeah, Addy, dude, how many gift cards have I bought you? You know it's real, dog, right? People are always like, is this non-profit real? I'm like, yes, dude. Look at all the receipts I got. Okay, you can pull a 4 out of all this, right? So this is the same thing as the square root of 4, 1 minus sine squared theta, times 2 cosine theta d theta. And then the trick here is that 1 minus sine squared theta, this is the same thing as cosine squared theta. Oh, you're gonna get your fourth one? Nice, dude. Nice. Cosine squared theta. Okay, cool. So now we have integral of the square root of 4 cosine squared theta to cosine theta d theta. And so, what is that? So, square root of 4 is 2. Square root of cosine squared is cosine. So now this is the integral of 2. Oh, and there's another 2 here. Okay. So, sorry. There's 2 times 2. And then you're going to have cosine theta, d theta. You have a statics exam in the morning? I'm cooked. Exam, dude, that's brutal, dude. 85%. My final exam in quantum mechanics was 90. So this is 4 cosine squared theta d theta. And then this one I think is a half angle identity. X equals 2/3 sine theta. I think is better here. Is it? Oh, I haven't even looked at, sorry, I haven't even looked at the bounds. Oh, I fucked up. Oh my god, whoa. I was reading what he had up to here. I didn't see the 9. Okay, let's backpedal. Dude, this is all wrong. Oh, I'm so sorry. So sorry. This is all wrong. Yeah. Okay. Let me start from the beginning. I read this question wrong. Shit, we got 8 minutes. I can do it. 2/3. Okay, this is 4 minus 9x squared dx. Okay, let's get rid of this. All right. You need to get this by itself. So what we're going to do is we're going to factor out a 9 from each of these things, okay? So this is going to be the same thing as 0 to 2/3 square root. And then I'm going to factor a 9 out. And so then that's going to be 4 over 9 minus x squared. Right? Did I do that right? I think I did. Yeah. dx, right? Yeah. So this came off of this, which means this now has to have a 4 over 9. Okay. Yeah, you can't do dank memer here. Sorry. Okay, so then this is 3 square root of 4/9 minus x squared dx. And now you say, okay, a squared equals 4 over 9. So thank you, Zach, for pointing that out. I was like, this is way too easy. My grade function hasn't collapsed yet. You mean your wave function or grade function? Okay, so x is equal to 2/3. Sorry, what do we want? 2/3 sine theta. Yeah, okay, 2/3 sine theta. dx equals 2/3 cosine theta d theta. Right? Cool. Let's replace. We'll eventually fix the bounds. And then this is 3. So this is going to be the square root of 4/9 minus this squared. And then this is now this. Okay. We'll start copy pasting just to make things faster now. Okay. Squaring this inside, this now becomes 4 over 9 sine squared theta. Okay. Which now you can pull the 4 over 9 out. So I'm going to say that's the same thing as 4 over 9 times 1 minus sine squared theta. Which now, that's equal to cosine squared theta. So this right here is right, cosine squared theta. Good. And then if we take all the square rootsies of that stuff, that's going to be equal to 2/3 cosine theta. Oh, cool. And there's another 2/3 here. Okay, cool. So that's going to be 3 times 4 over 9. Integral of cosine squared theta, d theta. Oh, you're lagging? Oh, no. Oh, yeah, I just saw... Oh, we're dropping frames now. Fuck. No, that's my fault. That's doing it. I see it. Oh, Twitch! You were so good, Twitch, until the last 5 minutes. Damn it. That's okay. One sec. Thank you, Swad. Yeah, I was looking for that identity. Right, okay. Okay, so then this is... Is it 1 plus cosine 2 theta all over 2? Right, d theta? Okay, so then that's equal to 4/3. Then we're going to say integral of 1/2 d theta plus integral of 1/2 cosine 2 theta d theta. It'll fix itself. It'll fix itself. Okay, so that's 4/3. Can I reply about your comment? And then separate, yep. All right, one sec. 1/2 theta plus 1/2. Integral of cosine 2 theta is then another 1/2 sine 2 theta. Good, okay. Okay. And then we got to remember that theta. Oh, okay. And this was kind of the whole coup de grace. Okay. So, 3 over 2x is equal to sine of theta. So theta is equal to arc sine of 3 over 2x. So now it's 4/3 times 1/2 sine -1 of 3/2 x plus 1/4. Oh man, this is fun. Sine of 2 times the inverse sine of 3 over 2x. Oh god. And then this is all evaluated. What's up, Pen? Apologize, my internet connection's like totally lagging out at the end here. Yeah, it's fucked. Shout out to Pen. Cool. All right, and this is from 0 to 2/3. Okay, this is a real pain. Okay, so that's... You're very welcome, Addie. Thanks for coming by. 1/2. Okay, cool. Watch, this is sine inverse of 1 minus sine inverse of 0 plus 1/4 sine of 2 sine inverse of 1. Wait, yeah, okay, 2 sine inverse of 1 minus 1/4 sine 2 sine inverse. Oh, fuck. Oh, my God. Ugh. Dude, this question sucks.
Surprise, motherfucker.
Seriously, dude, what the fuck? Okay. Sine inverse of 1 is saying what angle do I get 1 when I take sine? That's equal to pi over 2. And then sine inverse of 0 is equal to 0. Okay. I have 4 seconds left. Oh, so the stream's actually right about to end. This is the last one. That timer just ran out. I have to go teach another student at this point. Also, my internet connection is shitting the bed on Twitch right now. So, okay. This is pi over 2 minus 0. Oh, that would have been nice. Bro, I miss your long hair. I don't think I ever had long hair. 2 times pi over 2. Wait, right? Minus 1/4. You're right. I could have done the sine cosine identity, Zach. Thank you. I didn't do it. 2 times 0. Okay, this is all 0. Sine of pi is also 0. Okay. So our final answer is 4 pi over 12, which is just equal to pi over 3. Nice. Okay, cool. Done. I think it's done. I think that's right. Cool. All right, let's end on the stream. I gotta go. All right. Thank you, everyone, for coming to Actual Education Office Hours today. Had a really fun time going through all your questions. If I didn't get to yours, I apologize. Come by our stream tomorrow. We stream 5 days a week. So the next stream will be tomorrow, Thursday, starting, I think, an hour earlier at 4 p.m. Pacific. 5 p.m. Mountain. Wait one second. And 6 p.m. Central. 7 p.m. Eastern. Yeah. One sec. New post. What's up, Fire? Fopoop Gamma. Yeah. Okay, cool. All right. That was a really long one. But yeah, great stream. Oh, a year ago, I had long side hair. Oh, I had like a mullet. Yeah, no, I did. No, you're right, Eric. Thank you. 2 sins as a... Dude, Penn Center, you're fucking hilarious, dude. Okay, yes. So again, if you're watching us from all the platforms we're streaming on right now, which are absolutely raping my bandwidth, TikTok, Discord, Twitch, YouTube, there is actualofficehours.com. This website right here will show you how to join our Discord, how to like and subscribe to us on YouTube. Really appreciate it. It's great for the metrics. And you can also watch live on Twitch. And then we also have a streaming schedule here. So if you click here, you can see... yeah, you're very welcome, Zach. You can see the schedule of when we're streaming. So I will be streaming again tomorrow. Oh, and this is awesome, Zach. Ooh, Zach has a game night on Friday. Hell yeah. Oh, I'm totally coming to this, Zach. This is sick. Nice.
That's dope.
Yes, we're gonna go raid Stucky. Yeah, okay, that's what I was gonna say. Because if you're following us on Twitch, we love to go support other math and science streamers. So we're gonna go raid. Let's go raid. Let's see what we got. I have so many people now that are on. Where is Stookie? Where is Stookie? Stookie. There we go. Cool. All right, yeah. Eric's a great guy. He also does math and science, or mainly math, but awesome stuff. So yes, feel free, join our Discord. Send me a DM if you have any questions. I'd love to catch up, connect, talk, and answer any other questions you guys have. Okay, cool. All right. Enjoy the rest of your Wednesday. We will see you on Thursday. Peace.